Okay, we're coming around the home stretch from a very long day, and it will be rewarding probably by the end of tomorrow, hopefully. For those of you who are looking for the PowerPoints and you're like, my screen doesn't match your screen, and you've been downloading these here, I don't know what the difference is, but instead of going through and looking at it, I just uploaded my set here. So on the bottom it says 119 on all of these. This is the ones from today. Some of them may have been edited, some of them might be different. So I just took the ones that I pulled out for today, which were not on the online system, they were on a different system, which probably makes why they don't match. And I just tested them, they're all available right here. And for those people who have information overload, it'll be really easy for the next 45 minutes or so. Just going to finish up lecture number 1, and I'm decided I'm going to start with constructors tomorrow morning. Because there's some other concepts I kind of want to reiterate, and I think it might be easier to give you a fresher start tomorrow morning with constructors. And for those people who have anxiety, I can't learn this stuff, I'm not learning anything. Don't worry about it. You will. It's a matter of hearing it once, hearing it twice, hearing it the third time, hearing it the fourth time. And it's persistence for the most part, I think. And it's like anything that you're trying to learn. It might be completely brand new to you, and if it is, you might just need to let it digest a little bit and not worry too much. So I know it's really hard for me to say, but the way I've learned everything is just by having fun with it, just by playing around with it, and not worrying about whether I remember it or not, and just hitting it over and over and over again and drilling kind of thing. So everything today I've gone through, I'm going to go through again tomorrow, so you'll hear it again from me. So we were talking about, in this lecture here is lecture number 1, and you might get something out of reading through the lecture at a slower pace as well. And also that Deedle and Deedle book may also help you significantly, because then that'll be your second or third time through it, actually. So I talked about the object, I talked about fields and methods, we saw them. The get pencil, get color, set color. The fields we know are the variables, color, length, diameter. We didn't look at diameter, but that's okay. This is a method. So at the end of today, you might be happy to know that you probably could identify an object. If I put this in front of you and it said sample class, you probably know that that was a Java class maybe. The keyword class would probably tell you that. But this is a Java class. It turns into an object when it gets created, and these are variables, these are data members, these are member functions. That's the only thing that goes inside of a class. It's basically all we have. We talked about field declarations, we talked about the public, the private, protected. You'll get used to this the more you program with it. And just make things easier in your life, everything's public. Make things a little bit more protected, make it private. It's kind of like your data. If you put everything out on the internet, everyone's going to know your business. And it's not too protected. It's not everyone knows your business. Make it private. Don't put it out on the internet. Then it's very well protected. We went through an example of pencil and create pencil as well today, and we looked at how we were actually putting it together. We saw this live, and hopefully you saved the files. If not, well, you can easily recreate it by cutting and pasting out of the slide set if you wanted to. This example looked at the concept of static, which makes a class variable versus an instance variable. The same static method, the same static concept applies towards methods as well. So both data and methods, the two components of the class, they can be static. Leave out the keyword static, they turn into instance methods and instance variables. This keyword static is going to show up a couple more times. Don't worry about it for beginning level. It's more of an intermediate concept. It's just so when you see static written somewhere, you know what it means, hopefully. Well, you don't necessarily need to know what it means, but when you run methods and you run data from a static, you're looking at the name of the class instead of an instance of the class, which is the big difference. It'll trip you up a little bit when you look at it and you don't know what it is. So we went through this example here and we ran it. And we looked at it and we said that this code itself is only a purpose for showing usage of static. It was poor design. And it is poor design because we're actually printing out the data. When I said before, in a really good design, you want to have accessors and modifiers. And what does those mean? There's those setters and getters. So you're writing these methods. You're making the data private, which is the good design. And you're writing the public methods to get and set the private data, which is the concept I sort of wanted to drill in on that one. We saw the keyword final. We actually saw it in the Android app. And final means that once finalized, the value cannot be changed. We saw that. I can't remember what it was on anyway. I think it was on the screen or something. A lot of stuff in the a lot of stuff in the Android development environment is made final because they don't want you to mess with it. And one of the cool things is once you start recognizing, you know how to run a method, you know how to set a piece of data, how to do simple little stuff like that, makes your Android development so much faster because you can run through it and actually be able to look at somebody's code or look at pre-written code and have a better understanding of what it's doing, essentially, which you might actually have after today. We'll see about that. But final is used when we don't want to change something. It's sort of like constants or constant variables. We can initialize fields. We looked at some data types as well. I covered most of the contents of this lecture, which is why I'm kind of going through it faster to show you what's in it. But I showed you, instead of reading it out of the PowerPoint, I showed you using the source code examples. Don't worry about knowing every single data type that's out there. You're not going to know. I don't even know all the data types that are out there. After a while, you get kind of familiar with 90% of them. I hardly use Boolean for some reason, but that's a data type. You can set it to true or false. Object references, those are that P1 and the P2 from pencils. How do you know those? I can't imagine you can't memorize all those data types because some of them don't exist yet until you make them. So we don't know what those are. In terms of the method declarations, we have a method declaration that comes in two parts. We have this thing called a method header that we saw, and then we have the parameters that go along with it. We have a bunch of other stuff like the keyword abstract. We didn't cover this today, and we're going to cover it tomorrow because it's a little bit of information overload for you right now. But know that a method looks like a function, and here it is here. Here's the method body, which is empty for an abstract method. I'm going to talk about abstract stuff tomorrow, but know that this abstract means it's a concept. So something that's abstract is kind of like saying he's big or she's tall. How do you know tall? What is tall? It's abstract. We haven't defined tall yet. We're just saying it's tall. And then when you start defining, well, then you go, well, define tall, over 5 feet. Okay, well, that's actually kind of short for this medium, but that's what the abstract means. So in Java, we can say this method is abstract. And we use that in inheritance, which is why I'm going to show it to you tomorrow, because I'm not going to get into inheritance today. But if we created a base class, which is what we start out with at the beginning of the hierarchy, anything that's an original class is called a base class, and then we have derived classes that are made from the base class. I'll get into that terminology tomorrow as well. But we build classes on top of other classes on top of other classes, and when we do that, sometimes we don't want to define tall. We want to have a variable, a method, tall and short and medium, so we call them abstract. We say abstract void tall, or sample method or something. And then inside of here we say, well, if the person is below 5 feet, or above 5 feet inches, then they're tall, return tall, or something. And then when we do that in the derived class, we can have different interpretations of that for different scenarios. For example, a tall 5th grader is different than a tall adult, so that he or she's tall means a lot in different contexts. So when we create classes that have abstract methods, we know there's going to be this concept, but we don't know how it's going to implement. Depends on whether we're looking at a youth class or an adult class or something. So the method header itself is nothing more than this. Some people call it a prototype. It's really a method header or signature. Some people call it that. We have access modifiers, and the access modifiers, don't worry about this right now. We've actually seen the word static. We've seen the word final. We also have this abstract that works with that too. Much more on this tomorrow when it actually applies to inheritance. So we invoke messages, and we invoke assignments of variables through this dot notation that I showed you. So the method invocations is invoked as an operator or an object class by using the dot notation. This reference is the reference to the object. So if I said pencil space P1, P1 is the reference to an object, and the object type is pencil. And I can go P1 dot, and then it says method. Well, method could be get color, set color, And then the arguments are what we're going to send to it, like blue, yellow, green. And the syntax is going to be specific towards what information you're sending it. So if the arguments here in the method were 2, you'd separate them by commas. We'll see more of this when we apply it tomorrow with the Fahrenheits and the Celsiuses. But we could, for example, send more than one piece of data to this method when we call it. Depends on how we define the method and its usage. You might be wondering, well, how do we know what that is? It's all part of the public interface. And how do we know what that is? Well, we can Java doc it, automatically create the documentation, or share it, or you might have seen online, you see it all the time, like this blue and white kind of template that shows all, that's terrible. It doesn't make any sense to me, actually, because I look at that and I go, well, that's not very good. You know, it just shows you all the methods, the public interfaces to the methods, because how are you going to know how to run somebody's method? That's what you do in the Android class. You learn how to run the methods. And what are the methods? But does it really teach you how to Java program? No. It just shows you how to run methods. So the good thing is if you want to get into Android development, you can actually do a lot with a little bit of Java background. You don't have to be a good Java programmer. The more you know, the better you are. But if you can invoke a method, if you can realize that that's an object reference and you have a method and you have to send the method something, you can probably sketch your way by, make all sorts of different things, and run method calls on different objects real easily by following examples. Hard thing is to get it to do anything else. Then you have to actually write Java code. Then you have to know what you're doing, which is the skill hopefully you'll be picking up here. Or at least getting some exposure to. Remember, it's a beginning course. I'm throwing a bunch of stuff at you with the hopes that you'll take it past it. But if you walk away with a minimal, I've seen Java before from a beginner's perspective until you start working with it, that's actually pretty good. You know, at least you'll have more confidence in terms of your ability to learn it, perhaps. Hopefully you won't walk away, oh my God, I'm never going to be able to learn Java. I'm hoping that's not going to happen, but you know, it does happen with 1 or 2 people. And those people don't learn C either, or Objective-C, and they're not programmer types. I strongly, you know, I teach college freshmen over at Cal State East Bay, and we get the freshman CS students who come in. Some of them are programmers and some of them aren't. And some of them try really, really, really hard, but this stuff just doesn't click, and they don't like it at all. And it ends up happening is they drop out of the program after the first couple classes or so. And you know what? There's no harm in that. Maybe you're more of an artistic type. People who like programming are generally the mathematics type, because you have methodologies, you know, formulas, because there's a lot of memorization with this too. You know, as just looking at this slide right here, knowing about the dot notation and knowing about arguments and remembering, this is sort of like a formula, isn't it? I mean, it's kind of like a function. It is a function. A function here is a function there. It's the same thing. Sending a function to a function, and then you get into recursion, recursive functions, and then you get into Fibonacci kind of environments or summation kind of formats. And it's all mathematical. So people who like math love programming. They also like music, actually, because notations also relates to music. So there's a certain personality type that follows through a whole pattern of likes and dislikes. So don't blame yourself at the end of this weekend if you go, oh my God, you know, this just is not for me. You can probably still do well in here, but you might take it as a self-growth kind of awareness that maybe this, if you don't like it, that's another situation. But if you don't have a skill for it, that's not like any fault of anybody's outside of the fact that you're more of a this type versus a that type person. I'm, for example, really bad at UI design. I'm terrible with color combinations, terrible with art. Oh my God, I couldn't finger paint. I have no conception of putting pieces together visually. It doesn't work for me. But I can write algorithms. And I can do math, but I cannot do art. Everything looks like a third grader's art projects. I have no artistic ability. But I don't do UI design, so I'm good. And don't ask me ever to do UI design, which is kind of interesting because I can do app development. App development requires a very minimal UI. If you've ever seen some of these apps, and I usually call them clowns in a blender, You stick the clown in the blender, you roll it around. That's what my apps look like. They've got colors all over the place, stuff that flashes. It's kind of like people that used to use MySpace, you know, and they put all this HTML. It was when people first learned HTML, flashing text and animated GIFs and backgrounds, black backgrounds with white on it. And you look at it, it gives you a headache because it looks like you just put a clown in a blender and it threw up all over the page. That's what you need for apps, actually, because the more Blender is, the better mostly. But I shouldn't say that because I've just insulted all the UI designers out there. But long story short, for programming, you don't really need to be a good UI designer because in a big company, you've got UI designers that focus on that as well. And then UI designers, it's helpful to know the programming aspect of it, even if it's not your forte, and then vice versa. So it's really good if you're not a UI designer like me. I should be taking more design courses because I might be able to make a little more understanding about what the designers actually need from me. Anyway, back to the boring lecture. The dot notation, and then a static method. Then outside of the class, the reference is used through the class. Then we have non-static methods. Don't worry if you don't understand static versus not static at this point. It doesn't really matter. Let's talk about overloading. So a class can have more than one method with the same name as long as you have different parameter lists. So in other languages, if you have the same method with the same name, the compiler complains and says, hey, sorry about that, you know, I'll change the name. And it was actually kind of like the problem I ran into. I created the same method with the same name. And the only problem is I had the same number of parameters, which made it the same. And when it's all the same, the compiler doesn't like it. It wants something different. Otherwise, it doesn't know which one you're talking about. If I put another one in here, I just highlighted this float new price. And if I put in here pencil P, compiler's going to come back and say, which one do you want me to run? And that's a problem. When you have two methods with the same name, but they have different parameter lists, that's called overloading. Going back to what I was mentioning earlier, overloading leads to polymorphism. Because now we can run this method setPrice, and we can set the price to a new price. Or we can set the price to a pencil. And we can make the method work whichever one we call. So the compiler's smart enough to know if you send it a float, it'll run this one. And if you sent it a pencil, well, that's an instance of a pencil. That's a pencil reference P. Then it's going to get the price. The price is going to be equal to P.getPrice. A couple of different ways of running the method gives us more flexibility. So this allows us to kind of like, you know, overload, which means kind of make it more sophisticated. So how does the compiler know which method you're invoking? Well, it compares the number and the type of the parameters, and it uses the one that matches the one correctly. And here's a classic example. If I had two of them, like I had them both, I had a float new price, comma, pencil P. And then down here I had pencil P, comma, float new price. And I reverse the order. Well, it's different. It's not identical. So as long as it's not completely identical, you can make it so that the main program, you can set the price by putting a float in and then a pencil second, or a pencil first and then a float second, and it just will pick the right one. So overloading makes it a little bit easier for the programmer to actually put something together. As an example, take a look at system.out.print. That's an overloaded method. What does it print? It prints, well, there's print line as well, but print will print out anything. You just stick something in there. It picks the method to run. That's a method call, by the way. You're running print, or you're running print line, which is a different method. Print line is going to put an extra line return at the end of after it prints something out. Long story short, it's this concept. We have different print lines and we have different prints that take different things. By default, you want to put a string in there, but you don't have to. You can run on one of the different method combinations and it'll work. So with that added flexibility, you have confusion on the most part for most brand new people because they look at that and go, I thought you had to put a string in there. No, you can put a number in there. It'll take the number and convert it to a string. Oh, well, so it's kind of like breaking the rules, but it really isn't. So in terms of our methods, we have parameter values. The parameters are always passed by value, as I mentioned before, value versus reference. And here we have integer a, which is a value. The reference would be pencil P1 is a reference. P1 is a reference to an object. The only thing different is a value is a reference to a primitive data type like integer, float, double. And a reference is a reference to an object type. you know, like a pencil or a pen or an eraser, something like that. So here we have void method 1, integer a, that's a value. And then here we have nothing, we just have void method 2 with nothing in it. And usually you see that with no space in between. In fact, I would take the space out. Some people like to put a space in there because then you can see that there's nothing in there. In other languages, you can actually write the word void. You can actually do that in Java, but you'll never see it. It's because if you're that, you know, specific, and you want to make sure that the user sees that it really is empty, then you put void. Void means empty, if you haven't figured that out. It's void is nothing. It's void. It's empty. So here we have method b, integer b is equal to 3. Run method 1 with b, so we passed b into it. Now b is equal to, b is equal to 3, because we sent it over to the method and we said that, where's method 2? Here's method 2. And we sent method 1, a is equal to 6. Well, b is still equal to 3, because it didn't return or change anything. So when the parameter is an object reference, it is the object reference, not the object itself getting passed. And a little note on the bottom, hadn't we said it was all passed by value, not reference? It is and it isn't. So you're using it, for those people who don't know what pointers are, that have never seen references in any other language, this makes absolutely no sense to you. For those people who do, think of it, if you were to do this in any other language, it would be a reference, but it's a value. But it's being treated like a reference. But Java is doing that for you automatically, and you'll be happy to know there's no pointers in Java. Absolutely no way of programming with pointers if you're familiar with that. If you're not familiar with a pointer, then you've just saved yourself a big old headache, because you don't have to worry about that. Other languages, you've got this pointer concept. But Java, again, does automatic garbage collection, so you don't have to create manual pointers. You can use the concept, but you don't have to do it yourself. The compiler does it for you. Pointer is an indirect reference to memory. And if you didn't get that part, don't worry about it. I'll go over references again tomorrow when we send, we're going to use tomorrow, we're going to have a temperature that's going to take as a parameter another temperature, and that's going to be a referenced object. We'll see how that works in that example. The reason why I like those examples and the reason why we're going to write those programs, and those programs are part of your assignments for the course, is because it reinforces all of these concepts. It just puts them all together in one application, which is kind of cool. So here's another example. The example is a parameter and an object as an object reference. And the class is called passRef. And in here we have a void main, and we have a pencil. Plain pencil is equal to new pencil plain. And this is all on one line, by the way, but it's scrolled on this particular PowerPoint. In fact, I don't know if I make it any bigger. If I make it big enough, it would actually kind of go off on one line again. But if we were to run this, what we've seen so far, and let's just look at this line of code right here. If we said pencil P1 equals new pencil, and we don't put anything in here, then we're not using a constructor. When we start using constructors, we put something in here and we say it's plain. Maybe it's taking on the name or something. And then we can say something or we can do something with it. So here we have the original color where we're printing out the color. And then down here, system out new color plus pencil.color. And then here we're going to paint red plain pencil. So we're doing another method call where we're running a method paint red. And we're sending it plain pencil, and plain pencil is this pencil up here with the name plain that was attached to it. Don't worry about it if you don't understand the syntax right now, but this is just showing you all of the different combinations that might exist in your programming to look forward to tomorrow, where we'll be sending objects. This is an object that's being passed. But for those people who have seen this before, no reference notation like a pointer. It's automatically for you, which is the beauty of it all. No ampersands, no pointers or anything, and it is a reference actually, but it's being passed by a value inadvertently. So don't worry about the rest of this example. It's what we did already. You know, where we did p.color is equal to red, p is equal to null if we want to. And this is just some sample code. And if you read through the explanation of it, it's just showing you the, the color. Here's the parameter, and it's going to be equal to plain. Some people, this is the same thing that we looked at when we sent a color to, or we changed the color of a particular, hello, a particular color of a pencil or something of that nature. So, the main method concept, and stop me as we go through this if you need any further clarification. This is kind of a review of all the stuff we went over today. The main method concept is the driver program, as I called it. The only way we can tell the driver program from any of the other .java files that turn into classes is this is the only one that has a main method in it. The main method is the starting point for the class. So we have all these other classes, and we know that each class is defined in its own file, and it's called the name of the file. So if it's pencil with a capital P.java, it turns into pencil with a capital P.class. And inside of the main program, in our case, we called it create pencil. It could have been my main program. You can call it anything you want. What makes it the main program is this main method. So the system locates and runs the main method for a class, and then that runs the program, because that makes all of the instances of pencils and everything else that we might have in there. Other methods get executed when called by a main explicitly or implicitly, and it must be public, obviously. If you make the main method private, it can't run. How are you going to run it? So it's got to be public. And also static and void. Most people cut and paste the main method and use it over and over again. It's always the same. Main method looks the same in every single program that you write. It's always going to be the same. Main method that gets input from the command line. We've seen this already. Here's just a better explanation of it. It takes on this string, and this is the argument string, and the string argument is an index, and for those people who have never had this concept before, have never seen arrays before, this is where I say pick up one of those Deedle and Deedle textbooks. And the concept of an array is the same in any other programming language. It's a basic concept. It's associated with programming for storing multiple of the same under the same variable name. So instead of having just one string, we have 3 strings or 4 strings. And so when you run a program, here through the Java command line, the array arguments here and this command line interface only works from a command line. It does work when you pass information between apps and apps, if you can make it work correctly, but not often used. In fact, who writes DOS console applications anymore? Nobody. Everyone thinks GUI, everything is Windows. Not used very much either. You might notice some of your desktop apps, though, you've got stuff set when you run a program that might set a switch or something. That's a command line argument. Not a bad idea to be familiar with what a command line argument is. When are you going to use it? Probably never. So it's not a big deal if you don't have the syntax down. But notice that when you type in the name of the program and space, and you type in a couple of little things, strings, numbers, whatever you type in gets grabbed by the program. And that's the command line arguments. It gets parsed. It actually gets put into a string array right here. And in the string array, you're going string name 1 is equal to this argument 0, 1. I'm going to talk a little bit about arrays tomorrow, actually, because I have noticed some people don't actually have that background. So we'll hit a little bit on arrays, because we probably won't get into double and multi-dimensional arrays, but the array concept is helpful, especially if you want to take a bunch of objects and stick them in an array. You use arrays when you want to keep track of a lot of data, and you don't want to have P1, P2, P3, P4, P5, P100, and it's all over your code. And I used this word the other day in a different class, and someone went, I don't understand, but have you guys ever heard of spaghetti code? Spaghetti code? You guys heard that word before? And some of you have. Spaghetti code? See, now that we're almost towards the end of the day, I can mention spaghetti, because I'm probably going to have it tonight now. Now you have noodles in there, you have sauce, American spaghetti. You guys are international. Some of you guys are international. The Italians, I think it's not really Italian. I think noodles came from China, but don't quote me on that either. Anyway, long story short, it's called spaghetti code because it's really hard to identify what's inside of it. It's kind of like a plate of spaghetti. The spaghetti that I like has this like bolognese sauce on it, right? It's a tomato-based sauce and it has sausage in there, maybe hamburger. I love it with bell pepper and mushrooms. So I'm getting y'all hungry right now. I'm getting myself hungry. You throw a bunch of stuff in there and you mix it all up along with the noodles. And sometimes you can put multiple different types of noodles in there. The more variety, the more interesting, the more flavorful it turns out being. It's kind of like a stew. So then you scoop up and you never know what you're going to get. So when you write spaghetti code, that's a really bad thing. It's good with pasta, it's good with Italian food, but it's really bad for programming. That means inside of the code, instead of using an array as an example, you got 100 pencils. You got a pencil over here, you got a pencil over here, you got a pencil over here. So when you look at this person's code, that spaghetti code, you can't find anything. If I were looking at a plate of spaghetti and I say, how many pieces of mushroom are in there? It take you forever. In fact, what you end up doing is have to pull the mushrooms off and put them on the side of the plate. Which is kind of interesting when you say, I don't want onions on here. And they give you onions for me. And then I pull all the onions out. And at the end of the meal, you look at the plate, it's full of onions. It's this big old pile of onions that I've pulled off. And I go, whoa, that's a lot of onions they stuck on there. But I never knew that because it was all mixed in. So it's the same thing you get with spaghetti code in programming. So at least you'll remember this out of today. Spaghetti, don't want spaghetti code. You can't find anything. You can't count up how many you have. You don't know what you have. Instead, it's all over the place. So you try to fix something and you go, where's P1? Oh man, you look through these pages and pages and pages of source code and you can't find the declaration of P1. So what ends up happening is you start organizing the code. It's kind of like people that are type A and you go to one of those, cattle prod lines. You heard of that, right? Moo, as you're going through the line, buffet kind of thing. You have a plate. Some people are very meticulous about where they put stuff. They don't want the stuff to touch. So they get multiple plates. There's an order. There's a system to it. So when you get back to the table, everything's like clearly mapped out. It's not spaghetti. It's all clearly, not labeled, but it could be labeled, but it's clearly identifiable. You do that with your source code, so that all the variables are here, all the methods are here. All of the instantiations are here. And if you organize the code correctly, it makes it more maintainable. It makes it easy to edit, easy to modify. The use of arrays helps you achieve that. So instead of having 100 P1s, which you can very well do, you never actually have to program with an array at all in your entire programming career. However, you'll be writing a lot of spaghetti code if you're working with a lot of the same data. So if you have 100 integers, 100 pencils, you make an array of that data type. You take all those 100 and you stick it in the array. It's kind of like getting a basket or a separate plate out and sticking it all in the separate plates. And then you just, oh, where's that spaghetti? Here it is. And then you go to the plate to get what it is you want. And you look in the array to see which pencil's number 3. Here it is, number 3. And it's a better organizational scheme. So people who are afraid of arrays have a tendency to write spaghetti code because they don't want to put everything all together. They keep it all separate, and then it's all over the place. Spaghetti code also refers to other problems in programming as well, but we'll just leave it at that. So we know about the modifiers for classes. They're actually the same as the modifiers for methods and the modifiers for variables, and maybe you'll walk away with the concept of the modifier. So remember, before integer I, we stuck private integer I or public integer I. Well, in front of the class, when I created the pencil, I put public class pencil. Same concept that applies to everything inside of it applies to the outside too. So the main class can be public, private, protected. Usually it's going to be public because then you can't use it. If you have a final, can't be a subclass, you can't inherit from that. We don't know about subclassing yet. Abstract, no object of that class can be created. And then public means it's available. 9 times out of 10, the classes you're going to create are going to be public classes. You'll see that in your Android projects, it automatically comes up, everything is public. Public is actually, the keyword is optional because if you don't put it in, it's always public. So normally a file can contain many classes, but only one public one, which means only one is really going to be created and used. And the file name and the public class name should be the same as we mentioned before, so it's the same concept. Oops, oh, that's the end of the lecture. That's all that was in here. I'm going down to the bottom, and I know you're already ready to go. All right, so I'm going to hang out for about a half hour or so to catch any miscellaneous questions, and I'll come over and see you because you got your hand up. Unless anyone has any questions, comments, or concerns.
You don't have to do the assignments tomorrow.
No, nothing is due tomorrow. You don't have to do anything. Just show up tomorrow. Rest.
What is the due date for those assignments?
I don't know yet. I'll tell you tomorrow. Rest. Come back tomorrow at 9 o'clock in the morning in here. And then, trust me, it will be an easier day. It will be an easier day, actually. So I'm going to end this video. I will also show you where this stuff is going to be. Actually, I'll do it right now for those of you who are kind of curious. If you showed up late, or if you have a problem, if you couldn't understand half of what I was saying earlier, but now you think you might get it, but you want to relive today over and over again. In about a couple hours from now, once I start my uploads, they're going to be right here. I will also point this out tomorrow morning, but all of the stuff that I've been doing today has been recorded. It's in about 5 or 6 different parts as I've been taking breaks. So it'll all hopefully be labeled, maybe. I don't know, we'll see what happens. But I'll put it all up in here so you can relive it and see what I said. Otherwise, I will see you tomorrow.